Inverse Laplace Transforms Lecture 4.
Please subscribe to our channel if you like our videos.
You're welcome. Today we are going to consider Laplace inverse transforms. If you remember, in our first three classes, what we've been dealing with is how to find Laplace transform of a particular function f of x. Now today we want to consider the opposite of it, which is inverse of Laplace transform. So as you can see on the board now, today we already have the information on the board, because we know that Laplace transform of 1 is 1 over x. Now the question is this: what is Laplace inverse of 1 over x? That is what? 1. And then look at section 66.1 of this textbook, which I'm going to use to guide you. If we have sine at and we find the Laplace transform of this one, we can see here that the Laplace transform is a over x squared plus a squared. Now, what is the Laplace inverse of this? That is what? Sine at. That is all. It's as simple as that. If you notice, we notice that you agree with that we actually spend quality time to understand the Laplace transform of functions. So, because by the time we understand that one, to get the inverse is much more easier. So let's go to 66.2 now. We have this function 1 over x squared plus 9, and the question is this: what is the inverse of this particular what is the Laplace inverse of this? So now let's take a look at it now. Look at what we have now. We have we already know that inverse of a over x squared plus a squared is what is sine ax. So definitely, if you look at what we have inside the two now, look at the two now, you see that they're almost the same thing. But the question now is this: by the time you have 3 squared here, look at it, we just change this 9 to 3 squared here now. Now, if it is 3 squared, we know that a must be at the top. You remember, look at it now. We have a here. So a is what? Is 3. So by the time you put 3 here, you need to come and put 1 over 3 here, because this 3 here, we cancel this 3 here. So that is why you can now see now that the answer is 1 over 3 sine 3t. Now let's proceed now. Let's take a look at this table now. 1 over x is 1. Then inverse of 1 will give us back this one. Laplace transform of k over x. If the function is k over x, if we have the Laplace transform of the function is k over x, then the inverse of k over x is what? Is k. So 1 over x minus a. The inverse of this one will give us exponential at. So like that, you can see now we have how many of them? We have like 15 of them. Now another thing before we proceed is this: you see that of t raised to power t squared, t raised to power n. Look at it now. N factorial over xn plus 1. That is inverse of this one will give us t raised to power n. And look at this table too. You will see clearly down from here. All these things we've talked about it in our class. So let's go now to the second problem. 5 over 3x minus 1. We want to find the inverse of this. Now looking at this, you will see now that what we have in here is 5 over. I intentionally factorize. We can factor 3 out of this one, because 3 times x will give me 3x. Then 3 times 1 over 3 will give me what? 1. So that is okay. There's no problem there now. Can you see that? So just expand this. If you expand this, you will get this problem back. Now from here, 5 over 3 can come outside to give us 5 over 3 Laplace inverse. Then we have 1 over x minus 1 over 3. And looking at this very well, you know, in this case now, this is our a now. So if this is our a, then we can say that this is 5 over 3 exponential 1 over 3t, because this is my a. And don't forget that if this is a, then here too I have 1 over 3 here, which is what we have here to be 5 times 3. You know, this one 5 over 3, we can break this one out to give us 5 multiplied by 1 over 3. So that is how to go about it. Now let's proceed to this example now. We are asked to find the inverse of the following. So we have number 1, 6 over x raised to power 3. Now look at this now. 2 over x raised to power 3 equals to t squared. So from here, the inverse of this one is what? Is t squared. So the second example, 6 over x raised to power 3, then the inverse of this one will give us 3t squared. So that is all. You just notice that they are all simple now. Even look at this example too. 7 over x squared plus 4. Remember, if we have plus here, then we are talking about what? About trig, that's cos. And if we have a here, this a here we can express in terms of 2 squared. So then we are dealing with cos 2t. Then it's going to be x. So this 7 can come outside. So you can now see now that from here. You know, if you look at this one, we have used linear properties. So 7 can come outside, then you have this one to be 7 cos 2t. Now let's take a look at this example again. Now look at this one, we now have minus here. And when you have minus, that's trigonometric, that's cos, that's hyperbolic function. Okay, that is cos. So instead of 16, that's 4 squared, then we have cos 4t. So that is how to handle that. You can answer that. It's very simple. So let's take a look at this example again too. Laplace inverse of 3 over x squared minus 7. This is very simple because looking at this one, we need to express 7 in terms of square root. So if you put square root here and you put square again, you will now see what I'm talking about. But before we proceed, let's take a look at the solution now. Don't forget that inverse Laplace of a over x squared minus a squared is what is sine 80. You have negative for hyperbolic function. Okay. Now look at this now. This is 3. 3 can come outside to give me 1 over x squared minus 7. So if that is the case, this 7 here, I can express 7 in terms of square root square. Now, because you will notice that square root of 7 square is same thing as well as 7. So from here now, you can now see now that the answer to this one will now be 3 sine square root of 7t. That is what we are going to have. So if you look at it now, that is what we can have, and that is the answer. So you have this again, which is very simple again. So if you check your lecture note, you see more examples. Now look at this one again. We have 2 over x minus 3 raised to power 5. But from here, remember, we are using translational and scaling properties there now. That is what we need to use because we already know that 2 over x raised to power 5 is what? Is t raised to power 4. Now, if you shift it away from 3, that is why you can now see now that we have 3t, exponent 3t. Don't forget in your exam, in your lecture note, I said there's a place we consider. We said if Laplace of f of t is equals to f of x, then Laplace transform of exponential at f of t is equals to what? Fx minus a. You remember that? If you open your lecture note, you see the translational and scaling properties. That is actually what we use here now. So that you can see from here now that 2 over x minus 3 raised to power 5 will give us. The question now is this: where do we get 1 over 12? Remember that if you have 1 over x raised to power 5, that is actually t raised to power 4 times 4 factorial. That is 4 times 3 times 2 times 1. That is how we obtain 12 here now. So you just put 12 and you put 12 so that it can take care of that. So looking at that, you can now see clearly now that this is a simple problem. Now let's now go to the case of fraction. Now, problem number 5, we are going to solve 2 examples. If you look at the first one, we have 3 over x squared minus 4x plus 13. Now let's take a look at this one. That was exactly what I was trying to solve in the class. That was yesterday, 4th of March. And I said I was trying to jump, but many of you could not follow me. Now let's take a look at this example now. Now that we are through, I think we can jump now. Look at this very well. X squared minus 4x. From here, you know clearly that this one will give me minus 2x minus 2x, isn't it? I can break minus 4x to give me minus 2x minus 2x. And with that, I have 13. Then by the time you square minus 2 squared, that will give you 4. So we have 4, we have 3, we have 4, we have 3 squared. That is 9. So 4 and 9 will give us 13. So we can now manipulate the sign. So from here now, you can now see clearly now that from here, I will have 3 over, if you break this one down, x squared minus 4x, that will give you x minus 2 squared, then plus 3x. So this is the same thing as this. You all agree with me? The denominator here is same thing as the denominator here. So if that is the case, then you can now see now that this is, we've used shifting and translational properties here now. So, you know, this is minus 2. So that will give us exponential 2t sine 3t. The same thing applicable to this problem too. But this one is going to be cos because you can see now that we have x plus a. And then the shifting, that will be exponential minus t. So that is how to handle that. But there are some cases, even look at this example here now. We have this one again, 5 over x squared plus 2x minus 3, and the other one. So let's go down. Look at this one. If you have x squared plus 2x, this will give me x squared plus 1x plus 1x, then plus 1 squared. Then what will you now add to it to give you minus 3? Then you have this. Can you see that now? Can you see that? It's very simple. Now, from here now, you can now see now that shift, translation and shifting properties. So that will give us 5 over 2 is minus t sine 2t. So let's take a look at this one now. 4x minus 3. Definitely, this will give us, that is exactly in terms of cosh. So let's solve it together now. 4x minus 3, I still have the denominator, the denominator is what I will change now. This will now give me, no, okay, you remember they call it completing the square. Yes, exactly. You can use that idea to completing the square method. Do you remember? Because the only thing now is this, we want to express this denominator in terms of square. So I think you can do it like that. Because for this case now, by the time you expand this now, this will give me x minus 2x, then plus 4. Then plus 4. What will I add to plus 4? That will give me minus 5. That will be minus 3 squared. So that's how to go about that. So without cutting the, let's break it down. Let's go to another problem now. Okay, we have this exercises. But another thing now is this. You know, in all these cases, it's possible for us to jump. But there's some cases whereby we need the knowledge of partial fraction. No matter how big, how cumbersome the fraction is, we can use partial fraction to break it down. So let's proceed to 6.3. So now the first example we're going to solve here is this. 2x minus 3 over x into bracket x minus 3. This is a fraction which we can easily break. How do we break it down? Because this is multiplication. So it's the same thing as this over x plus something over x minus 3. So let's call it a and b. So if you remember now, that is partial fraction. So that is how we're going to use the method we're going to use to break it down, because you cannot say that as cumbersome as this function now, we can break it down to something simple like this. So, and we know that 1 over x, Laplace transform of 1 over x, that is 1. We know that of 1 over x minus a, that's exponential 3t. You now see now that is very simple. So let's take a look at this example number 1. We have the function to be 4x minus 5 over x squared minus x minus 2. So how do we go about it now? Let's take what is inside. This is the fraction we are dealing with. This is the fraction, and then is equals to, because it's possible for us to break down the denominator. You can see now that the denominator, we can easily break it down to x minus 2 into bracket x plus 1. So if we can break it down like this now, so what we are going to do now is this, say a over x minus 2 plus b over x plus 1. That is what we have here now. This method is called partial fraction. It's very simple. We are just trying to break a big fraction to small fraction. So what do? A over, because we can easily separate, we can write the denominator in terms of this expression. So we have a over this, b over this. So what is the next thing? You multiply both sides by the denominator. So the denominator will cancel. Then what we now have is a multiplied by x plus 1, which is this one. Then plus b multiplied by what? X minus 2. So we have this. So from here now, we need to find a and b. So what do? Let's, by the time you multiply both sides by denominator, this one will disappear. So what will now remain is 4x minus 5. Okay, and this. So that's how we obtain this expression here. So the next thing is this. We want to set this one to 0. So how do we do that? That is when this x here is plus 2, this one will go. That's why we say that x equals to 2 here. Then by the time you put 2 here, 4 times 2 minus 5 is equals to a into bracket 2 plus 1. That will be in 3a. Then this one will go.
Come now, you will now see what we are actually trying to do is that we are trying to find inverse of 4x minus 5, then divided by s squared minus x minus 2. This one here is very simple. Why do I say that? It's because I already know that the product and sum of the denominator here. That is why I say it's very simple. See, look at me very well. You notice that this is same thing as x squared, then minus 2x minus 1. Okay, then it can be minus, that will be 3, then plus 1x. Are we together now? Then minus 2. If you look at this way, you see now that this and this will give me back this one. So definitely I can say that this same thing as x squared, then plus 1x, then minus 2x minus 2. So if you join it together here, this will give me x into bracket x plus 1. Then at the same time, this will give me minus 2 into bracket x plus 1. So this and this will give me, so this is the same thing as x minus 2, then x plus 1. So looking at this now, you now see that it's very simple, because here I already know that this is the same thing as 4x minus 5 over x minus 2, then x plus 1. So this is actually what we are trying to find. Can you see now that? So, but that is not all. we need to focus on this particular fraction. And let me write out the fraction. The fraction is 4x minus 5 over x minus 2 into bracket x plus 1. So this one will give me a over x minus 2 plus b over x plus 1. You see that now? So what is the next thing now? What I'm going to do now is this. I will multiply both sides by the denominator. Do I need to write? Let me just write that multiply both sides by what? By x minus 2, then x plus 1, or perhaps I write so. So by the time I multiply everything here by this, are you with me now? It will cancel this. What I'm saying is that everything here, if I should put it down here, it will cancel this. So if it can, what will remain is what? 4x minus 5, then is equal to. If I should put everything here, this one will cancel this. What will now remain? X to the bracket of x plus 1, then plus. If I should put everything here, x plus 1 will cancel x, and then you now have b into bracket x minus 2. You see that now? So the next thing is this. We need to find our a and b. How do we get our a and b? What we need to do is this. Let me set x equals to minus 1 here. By the time I set x minus 1 here, this one will give me 0. So let my x is equal to what? Minus 1. So that I can find a, because by the time you have minus 1 plus 1, this one will go, then a will be 0, then I can find my b. So let me put that minus 1 here now. That will give me 4 into bracket minus 1 minus 5, then is equals to, this one will give me 0, then plus b into bracket minus 1 minus 2. So this will give me minus 4 minus 5, that is what? Minus 9 is equals to, that's minus 3b. So from here, I can say that my b is actually what? That is minus 9 over 3, and that is 9 over 3. I mean, that is minus 9 over minus 3, and that is what? Then that is 3. So that is not how we still need to proceed, because we need to find our a. So how do we find our a? Let our x equals to, here, if I should set everything to be 0, that is possible if I should set x equals to what? Plus 2. So if x is what? Plus 2, then b will disappear. So I can come back here to have 4 into bracket 2, then minus 5, then is equals to what? Is equals to a into bracket 2 plus 1. I mean, these two, I put it down here. If I should put the 2 here, this one will give me 0. Of course, you know, that's even how we obtain these 2 in the first case. So what we now have is 4 times 2, 8. 8 minus 5, that's what? 3. Then is equals to 3a. So from here, I can say that my a is what? Is 1. So that big fraction I was talking about, which is x squared minus x minus 2, is now equals to a, that is 1 over what? X minus 2, I mean this a. Then plus b, what is my b? 3 over what? X plus 1. Are we together now? So if that is the case now, so I can now proceed and find inverse of 4x minus 5 over x squared minus x minus 2. Then that will give us inverse of what? See, if you look at this, what I'm trying to do here is called linear properties. Inverse of 3 over x plus 1. You see that now? So what is the next thing now? This one here will give me what? This one will actually give me exponential 2t. And what about this one? This one will give me 3, then exponential minus what? Minus t. So this is the Laplace inverse. So let's go back and continue with the lecture notes.
Okay, you're welcome back. Now, you will now see that the problem we've just solved now is very simple because of the nature of that particular fraction. And if you open your lecture notes, you will notice where I actually list all the rules associated with partial fraction. So I advise you to pay attention to those rules, because the next example we want to solve now, we may not be able to easily know the root and sum of the denominator. Okay, now let's take a look at this problem number 8. We are asked to find the Laplace inverse of this particular problem. Now, look at this. We have what is known as repeated root here now. And what the rule says is that in the case of repeated root, we say a over the first one that we can separate, which is x minus 3. That is why you can see here a equals to what? X minus 3. Then look at this one, x plus 1 raised to power 3. This is known as repeated root. So what we are going to do now is this. We said ab over x plus 1, which is what is inside, Then we say c over x plus 1 raised to power what 2. Then we say d over x plus 1 raised to power 3. Now we already have the power now, so we stop at that. You see that? We stop at that. So this is another problem. Now you can answer that in this case, we use another rule, not like the first example, whereby we know the roots, the product and sum of the denominator just like this now. So this is quite different. So look at the problem again now. Even before we proceed, don't forget, I've advised you that you should check my lecture note again. Check it. You will see the rules. So in case you cannot have access, don't have access to it, please on Monday 8th, I will upload another video again where I'm going to explain how to use Laplace transform to solve differential equation. Then I will upload all the lecture notes, everything. But let's take a look before we solve exact problem 8. Let's look at problem number 9 again. Look at this one again. Look at the nature of the denominator here. You see now that the nature of the denominator here is quite different. So what we need to do here is this. We said a over x plus 3, which is what we have here. Then plus, because this one we have quadratic. We have quadratic. See, there's a difference between this one and this one. In problem 9, we have x squared plus 1. But in problem 8, we have x plus 1 raised to power 3. Because the power, everything here carries the power. That is why we can easily use this rule, which is x plus 1 raised to power 1, x plus 1 raised to power 2, x plus 1 raised to power 3. But here, we can't use the same thing. So what we do now is this. We now consider the lower power. So here now we have a over x plus 3, then plus bx plus c over x squared plus 1. Look at this, bx plus c, bx plus c, because this one is x squared plus 1. So that is it. So like I've explained, it's very simple because we're going to solve it together now. We'll go back to another form of lecture delivery where I will write on paper and I will show you how to do it. But the only step now is this. If the denominator is x plus 1 raised to power 3, we use it like this. If it is in terms of quadratic, are you with me? In terms of quadratic, cubic, quartic, like that, we are going to use the power of lower power on top of like this. So before we proceed, let's take a look at these exercises. Look at this one. Look at this one. Look at this one. Look at another one again. Problem 10. How do we handle this one? This will give us a over x, then plus bx plus c. See, look at bx. You can see that the quadratic here is squared, right? So we're going to use bx plus c. And then being the quadratic here is raised to power 3. What we use at the top will be squared. It's going to be bx squared plus cx plus d. So let's take a look at this. Okay, all this one, they are very simple anyway, because this one now, like this one now, we know that this one is same thing as what? This one is because what? A over x plus bx plus c over x squared plus 4x plus 13. So that one is very simple. And this one too, what about this one? This one will give us what? A over x plus b over x squared plus cx plus d over x squared plus 3. So we are going to break all this down. But before we continue, let's go back to our another lecture delivery and solve this particular problem 8.
Okay, you're welcome back to our classroom now. What we want to do now is this. We want to find Laplace inverse of 3x to the power 3 plus x squared plus 12x plus 2 divided by x minus 3 into bracket x plus 1 raised to power 3. So this is it now. Now look at this fraction. No matter how big it may be, we can actually write it in terms of small fraction. So this will give me 3x to the power 3 plus x squared plus 12x plus 2 divided by x minus 3 into bracket x plus 1 raised to power 3. Then this will give me a over x minus 3, which is, I'm already trying to split the fraction. Then plus, what about this one? This is repeated roots. Take note of that, repeated power. So what I will write now would be b over x plus 1 raised to power 1 plus c over x plus 1 raised to power 2 plus d over x plus 1 raised to power 3. So what is the next thing now is that we are going to multiply both sides by the denominator. So let's just look for a way to write that information down. So you can now say that multiply both sides by the denominator, which is x minus 3, into bracket x plus 1 raised to the power 3. So by the time you put the denominator, you multiply it by this one. This thing here, we cancel this. So what will remain now will be 3x to the power 3 plus x squared plus 12x plus 2 then is equals to a. Everything a, you put it down here. The x minus 3, we cancel this. So what we now have will be a into bracket what? X plus 1 raised to the power 3. Then plus b into bracket. By the time you put everything here, beside b here, so you are going to have minus 3. It will remain 1 here. The x plus 1 will take care of 1 out of this. So you still have x plus 1 squared. Then plus c into bracket. If you put everything here, multiply by this one, you have x minus 3. Then you have x plus 1. Because x is plus 1 squared, we take care of this. It will make this one to remain 1. Then plus d into bracket x minus 3. So look at what we're having now. So I think we're almost through with the problem now. Don't forget, what we're trying to do is this. We want to break this fraction down. Okay, and because of the repeated root here, which is x plus 1 raised to the power 3, then you can see we have x plus 1 square, x plus 1, 3. Okay, then what is the next thing now? We multiply both sides by denominator. So by the time you multiply the denominator by this one, it will take care of this. Then you have everything here, which is like this. Then you multiply, then you have this. So let's proceed and start the solution. So the next thing now is for us to start looking for the A, B, C, D. We look for them one after the other. So let's just look at it very well. But one thing you notice here is this. By the time you set your s equals to plus 3, something will happen. That is true. So something will happen. So let's start with that. Let our x is equals to what? 3. So that by the time you put 3 here, then that will give us 3 into bracket. That is 23 raised to the power 3. That's 27. That's 3 times 27. Then here, that is 3 square. That's 9. Then this one, 12 times 3. That is 36. Then plus 2. Then is equals to. So by the time you put 3 here, 3 plus 1, that is 4. Then you have a into bracket 4 raised to the power 3. Then plus, by the time you put 3 here, this one will disappear. By the time you put 3 here, it will disappear. So with this, we can find our a. So let us proceed. So if you do this one now, what you will notice is that when x is equals to 3, what we discover is 128 is equals to 64a. So from here, we can see clearly that our a is what? Is 2. Okay, now we need to take another step forward. How do we know what to do now? Let's take our x equals to minus 1. Why do I pick minus? Because by the time you put minus 1 here, it will take care of this. So let our x is equals to minus 1. So I'll put, by the time you put minus 1 raised to the power 3, that will give minus 1 times 3, that will give you minus 3. Then minus 1 squared, that is 1. Then by the time you put minus 1 here, this will give me minus 12, then plus 2, then is equals to, by the time you put minus 1 here, this one will go, so you won't have a again. By the time you put minus 1 here, definitely this will give you 0, then everything will go. By the time you put minus 1 here, this one will go. By the time you put minus 1 here, that will be minus 1 minus 3, that will be minus 4d. So by the time you press this one, what we discover is minus 12 is equals to minus 4d. So from here, our d is equals to what? 3. Now, we're almost through. It remains our b and c. I would advise you to pick any number, because what we need to find out is just like 2 by 2 equation. So let me just take my s is equals to what? 1. You can pick any value you like. So let me put my 1 here. 1 raised to the power 3 is 1 and 3. That will give me 3. Then plus 1 square is 1. 12 times 1 is what? Is 12 plus 2. Then is equals to, what about this one? 1 plus 1, 2. 2 raised to the power 3. That's 2, 4, 8. That will give me 8a. And by the time I put my 1 here, that will be minus 2. Then that will be plus b into bracket, minus 2 into bracket, 1 plus 1, that's 2 squared, that's 4. Then plus c into bracket, 1 minus 3, that is minus 2. Then 1 plus 1, that's 2. Then plus d into bracket, 1 minus 3, that's minus 2. So that is what we have here now. So what is the next thing we're going to do now is this. If we join this very well, that will give me 4, and at the same time, that is 4, 16, 16, 17, that's 18. So this will give me 18. That is 18 is equals to this a here. I will substitute 2 here to give me 16. Then 2 square is 4 minus 8. That's minus 8b. And what about this one? That is minus 4c, and d is 3 here. So by the time you put 3 here, that will give you minus 6. So look at what we're having now. So the same thing again. Let's proceed and let's just say let x equals to what? Let x equals to 2. So from here, you can arrange this and this together so that you have one equation. So you do the same thing here again. By the time you do the same thing again, you have another equation like this too. So you can now combine this one and the next one here to find your B and C. So I would advise you, when you're going for the exam, please go with a calculator that can help you to solve such a simultaneous equation so that you won't waste much of your time. But by the time you do that, you will notice that at the end of the day, your B will be equals to what? 1. And at the same time, your C will give you minus 4. So which means that we can go back now and substitute. We can now go back and say that 3x power 3 plus x squared plus 12x plus 2 divided by x minus 3 in bracket, then x plus 1 raised to power 3 is now equals to here now. We know our a now. Our a is what? That will be 2 divided by x minus 3. What is our b? Our b is what? Our b is actually equals to 1. Then that will give us plus 1 over x plus 1. Then what is our c? Our c is what? Minus 4 divided by x plus 1 squared. Then what is our d? Our d is 3 divided by x plus 1 raised to power what? 3. So that is all. Now, if we now find the Laplace transform Laplace inverse of both sides. Now let me write Laplace inverse of, this is actually what we are looking for. Is now equals to Laplace inverse of what? Of 2 over x minus 3 plus Laplace inverse of what? 1 over x plus 1 plus Laplace inverse. Even I can bring my minus 4 here to come outside. Then into bracket 1 over x plus 1 squared plus 3 Laplace inverse of 1 over x plus 1 raised to power 3. So look at this one now. This one will actually give me 2 exponential 3t. Laplace inverse of this one will give me plus what? Exponential minus t. And what about this one? That will be minus 4 exponential minus t, then multiplied by t. Don't forget that Laplace inverse of t is 1 over x squared. Then you extend it by 1 using that translational properties. Then what about this one? That will be plus 3 over 2, then exponential minus t, then t squared. Don't forget, see from here, Laplace inverse of t squared is what? That is 2
We share.
Tutorial questions and answers.
It is all about understanding facts and sharing with others.
Learning continues. We are learning to know, understand, and share with others.
Please subscribe to our channel if you like our videos.